So we've got a pretty simple apparatus for today's experiment. There's a rubber stopper connected to a string. The string is threaded through this glass tube. There's an alligator clip clipped onto the string here, and then goes down and is attached to this mass, which will be hanging mass at the bottom, capital M. So in practice, the tube will be vertical, swinging around, with this mass moving in a circle, and the string can slide up and down through the tube depending on the force required to keep this thing in circular motion and the tension from the hanging mass. So the alligator clip that's there on the string is to mark the length so that we know how much string is fed out the other end towards the rubber stopper. So if I put this with the ruler end at around the center of mass and slide the tube up against the alligator clip on the lower half, you can see the top of the tube is right around 40 centimeters. So that means the distance from the top of the tube over to the center of mass of the rubber stopper will be about 40 centimeters. And so that's the radius of the circular motion that it will be undergoing. I should note that in practice, we want to aim for this alligator clip sort of just below the bottom of the tube, and not touching it, because if it's touching it, then the tension from the hanging mass is not transmitted evenly up to the other part of the string. So when I'm swinging it around, usually you'll see the alligator clip sort of maybe a centimeter, maybe two, below the bottom of the tube. Usually I try and keep it still just below the bottom of the tube, without contact. So in order to collect data on circular motion, we're going to be using a series of short videos that I've posted to YouTube. Each of them features a couple seconds of me kind of setting up the motion. One thing to look out for is you probably want to start recording after I'm holding the tube up next to this little hanging nut. I use that to kind of hold it in place without moving around too much, and just to keep it centered in the video. So in order to get good timing, you can see there's a clock running on the screen. The run number is noted here, as well as I've got it as L on the screen, but you can just use that value there for R, the radius of the circular motion. What you can do to get a good timing, let's wait until we're ready to start. Okay, it's looking all right now. So I'm going to pause it, and in the settings here, we can turn the playback speed way down to 25%, and that will let us watch the video sort of in slow motion. And I'm going to be using the space bar, or you can use the K key to pause and restart the video. So what I'm going to do is maybe I'll call this position my starting position, where the bob is sort of on the right towards where I'm standing. And we can know the start time there is 44.7 seconds. It's pretty hard to read past the tenths on this timer, so I think the tenths is probably going to be sufficient. So we'll record the start time, and just for an example, I'm going to count out 5 cycles. We're going to be doing 25 in the lab. But so if I unpause, I would just want to watch carefully and count the number of cycles, the number of times the stopper passes this point. So if I unpause, and there's 1, 2, 3, 4, and 5, and I almost got it. I probably want to advance just a little more. So that looks like about where I had started, and so then 47.2 would be my ending time for this timing of 5 cycles.